Okay, welcome back. In this video we'll be discussing about the static net. Okay, so we have already saved the lab setup for the network address translation. I've just opened that. You can also open that. Now what is our target? We need to do the static net. What is the concept of static net? What is the concept of static net? Here 192.168.1.1 should be translated to 50.1.1.1. Similarly 192.168.1.2 should be translated to 50.1.1.2 and 192.168.1.3 should be translated to 50.1.1.3. right? See, I'm not going to translate 192.168.1.4. I'm not going to translate. Okay, we'll see what is happening. Okay, we'll see what is happening. So 1.1 is going to be translated to this, 1.2 should be translated, 1.3 should be translated to 50.1.1.3. already we know that this is an ISP router. Okay, so we'll go to the each and every PC and we'll translate to the 50.1.1. okay, we need not go into each and every PC and do it. See, every PC is being allocated to this R1. Through R1 only it is going to get communicated. So we'll go to this router 1. Okay, we'll do all these configurations in this router only. Okay, so we'll go to the R1 configuration mode. In the configuration mode, please make a note. Okay, here the command is IP NAT inside, IP NAT inside source static. What I should do, 192.168.1.1 should be translated to public IP 50.1.1.1. so similarly you need to do it for all the addresses. An IP NAT inside source static 192.168.1.2 should be translated to 50.1.1.2. similarly do it for IP NAT inside source static 192.168.1.3 should be translated to 50.1.1.3. that's all we have done. I'm not doing it for 192.168.1.4 because we'll see if it is not translated whether I'll be able to access the server or not. That we'll see through the 192.168.1.4. okay, now our next step is we need to find out whether which one is inside, which one is going to be the outside. Now this is our routing, default routing we have done. This is the router which is going to be connected with the internet service provider. So for this router, which is inside, which is outside. So this is my network, private network. From the private network, which is going to this one, gigabit Ethernet 0/0. This port is my inside port. Now what is the outside port from this? Serial port 0/0/0 is going to be the outside port. That we need to inform the router which is inside, which is outside. Okay, that is called as implementation part. Let us implement it. So interface, what is the port? Gigabit Ethernet 0/0. okay, this is going to IP NAT inside. So I have assigned it is the inside port. Next, outside port is interface serial 0/0/0. This is going to be the IP NAT outside. Okay, then I can end this. That's all. Okay, now I'll see whether I have done the translation. Show IP NAT translation as the command. Yes, see, now we'll verify whether we have done correctly or not. So you can see inside global, inside global, inside local. So locally private we have 192.168.1.1, which is being translated to 50.1.1.1. Similarly 1.2 is translated to 1.2 of 50. 1.3 is translated to 50.1.1.3. So very good, we have completed the translation of NAT. Okay, now what is actually outside local and outside global is when we are accessing our network. For example, when we are searching for google.com or yahoo.com, okay, then what is going to be outside, what is going to be outside local, and what is going to be the outside local. Now since we have not sent any packets, we have not created any traffic, this is nothing is there. Okay, we'll create some traffic and then come back to this and we'll see what is happening. So what I'm going to do, let me ping, let me search for Google, correct? So what is my Google server now? Ping 200.1.1.1 is my Google, right? So yes, very good, I have now accessed the google.com, correct? Similarly, I'll try to ping the Facebook. Ping 200.1.1.3 is my Facebook. Yes, I'm trying to ping it. So yes, first packet is an ERP packet, so it was not able to get. From there I'm able to do it. Okay, now we will see how this trace RT. Okay, I'll trace the route to 200.1.1.1. now from this, now how it is happening, you can see here. Okay, from the router it is reaching the 100 network. From the 100 network it is being going to go to the as 200.1.1.1. now we'll see what happened in the case of routing. Okay, show IP NAT translations. See here, so what happened, from the inside using the ICMP packets, using ICMP protocols, okay, I am able to access the server as well as I am able to access the Facebook. I have able to, this is nothing but network is my, this is nothing but my google.com, okay, as I assumed, and this is my facebook.com. so I'll be able to assign, I'll be able to fetch it, correct? So I'll be able to access the google.com as well as the facebook.com using the network address translation procedure, correct? So this is called as static NAT, understood? So I'll explain the concept now once again. See what I have done, I have taken a topology and this is the router and this network is there within me. For example, this complete network is within one organization called XYZ. I am taking NHCE Bangalore. Okay, the complete is there. Similarly, I need to go with the actual internet and not using the actual internet here. That is why what I have done, I have considered this router is with the internet service provider who is having the server details of all the other networks, like where is Google, where is Yahoo, where is Facebook. Okay, directly and I was not able to send a packet or receive it, otherwise I can say that I was not able to access any google.com, yahoo.com, because private addresses need to be IPv4 private IP addresses need to be translated to the public IP addresses. So public IP addresses are provided by the internet service provider. He has provided me for 3 addresses. For example, 1.1 can be 50.1.1 is my public IP address. Similarly, 192.168.1.2's public IP address is 50.1.1.2. Okay, so with that help of the public IP addresses, now I am able to access it. So let me see once again. So I told you that I have not given public IP address for this PC3. So from the PC3, I'll try to send a packet from PC3 to google.com. It is failed. Okay, so you can see in this place. Okay, I'll take a packet. So I have given the public IP address for 192.168.1.1. so I'll take a packet, send a packet from PC0 to server. It is successful, correct? Similarly, I am taking a packet from PC3, which is nothing but 192.168.1.4, which I have not translated to public IP address. So from there to here, google.com, it is failed, which means that once this translation is done, I'll be able to send a packet from this 190 to 160 to 1.4 also. Okay, this process is called the static NAT. So what are the disadvantages of this method? The main disadvantage is everything to be given, I need to go manually, I need to go to each and every router in the network and do this translations. I need to assign each public IP address separately to each private address. The second drawback is for n number of private IP addresses, I need n number of public IP addresses, otherwise I will not be able to communicate. Correct. So here I am not able to utilize, cannot able to utilize IPv4 efficiently. Okay, so the main objective of using the NAT is to reduce the problem of shortage of IP addresses. So that this is not possible. So in order to overcome this problem, we need to move to the next method called as dynamic NAT. Okay, we'll discuss about the dynamic NAT in the next video. Please do save this as a separate file. Okay, save it as a separate file. Okay, it is nothing but your static NAT, because we need the basic lab setup for doing the dynamic NAT also. Static NAT, I'll save it. Okay, and I can close this one. Okay, we'll see in the next video.